For this example, we're dealing with a sample of 40 cats, 47% of which preferred this food, and we want to know, can we conclude that's under 50% of all cats that prefer this? I want to do a one sample hypothesis test that involves proportions, because I have percentages, I have one sample of 40 cats, and I want to prove something. The first step is going to be to go ahead and list. When I list P hat. P hat's the actual percentage, which is 47. I have N, which is my sample size of 40, and P naught, which is 50%, because I want to show that it's under 50%. Step 2 is my hypothesis. When I list my hypothesis, I have two things. I have my null. I'm going to assume here that's actually 50% of all cats that feel this way. And I'm going to try and prove something different. My HA, my alternative, is going to be P is less than 0.50. It's less than because it's under 50%. Step 3 is my test statistic. When I go to calculate my test statistic, the first thing I need to do is go ahead and calculate SE. SE is square root P naught, 1 minus P naught, all over N. When I plug this in, I need to pay attention that I'm plugging in P naught, which is 50%, versus plugging in that 47%. Now I've got that written in, I'm going to go ahead and calculate it out, and I'll get 0.0791, keeping 4 decimal places because this is a proportion problem. After I calculate SE, and notice that SE is really large, that means I have a standard error of almost 8%. It's a large standard error because I have a small sample size. After this though, I need to calculate Z. Z is always my actual, which in this case is P hat, subtracting off my expected P naught, all over my estimate of my standard deviation, SE. When I plug this in here, I'm going to get a negative. And I'm going to get a negative because I have an actual value that is below my expectation. In fact, I get a z-score of negative 0.38. Notice this isn't a very large z-score. Now, when I go to step 4 here, I'm going to go ahead and find my p-value. I need to pay attention to the fact that A, I have a negative z-score, so I'm on the bottom half. And I want to show below, so I'm shading the lower end, which means I don't have to do anything fancy here. All I really need to do is go ahead and insert in my z-table and take a look at it. So with my z-table here, I'm going to go ahead and look for negative 0.38. Coming to the side, I look for negative 0.3. On the top, I look at 0.08. And I get 0.3520. So I'll write that over here on the side. That is my p-value is 0.3520. Now that I've got my p-value, the next step is to go ahead and reach my conclusion. Remember, I always compare my p-value to 0.05, what's called my significance level, or alpha. In this case, my p-value is 0.3520, which means my p-value is bigger than 0.05. If my p-value is bigger than 0.05, that means I'm going to fail to reject. It means there's not enough evidence to suggest what I'm trying to prove. In this case, there's not enough evidence to conclude that under 50% of cats prefer this.